All right, in this lesson, 361, we're going to talk about taking verbal descriptions and creating equations from them, something that all of y'all love to do. So, basically taking word problems and creating linear exponential equations that make sense. All right, a verbal description of a math pattern or situation will be represented using equations and expressions. Just a quick review of what a variable is, what an expression is, and then what an equation is. All right, so just a quick review of that. Make sure you pause it and read it. A lot of reading going on here. Make sure you're taking your notes on these videos. I'm not reading the whole thing to you. A function is a relation between two variables where one is independent and the other is dependent. A linear equation is two variables where both variables are raised to the first power. S equals 2r minus 7 would be an example of that. Slope-intercept form, y equals mx plus b, super important. Or for a linear function, f of x equals mx plus b. Same thing. And then, let's see here. Consecutive terms in a pattern have a common difference, which means you're repeatedly adding or subtracting by something. And then the other option is we have exponential. Those are the two we're going to focus on. So, an exponential function can be represented using an exponential equation. An exponential equation relates two variables, and a constant in the equation is raised to a variable. The general form is y equals a times b to the x power. Remember, you can't do a times b and then do it to the power of x. You have to do b to the power of x and then multiply by whatever that number out front is. An explicit equation describes the nth term of a pattern and its algebraic representation between two quantities. We're going to look at something here in just a second that is a little bit tricky with exponentials that we're really going to have to think about. The common ratio can be found in an exponential, and it describes a relationship between two quantities. B is your common ratio. In other words, it's the thing that you're multiplying or dividing by, depending on whether you're moving forward in the sequence or backwards. Let a sub 0 be the value of the dependent quantity when the independent quantity is 0. So a sub 0 is when you plug in 0 for x. The general equation would be represented by this. Okay, that's kind of the general way we set it up. So basically, we're setting it up for the 0 term, right? So we're talking the first, second, third term, something like that. We're setting it up, our general setup is for the 0 term. Let a1 be the value of the dependent quantity when the independent quantity is 1. So in other words, when x is 1, your equation actually should look a little bit more like this. Okay? So your general equation would be set up like that. And we'll look at an example of that in a second. Generally, you can figure out how to write it both ways, but you have to do a little bit more work because you have to understand that your initial value is actually your 0 term, which is going to be important here in just a minute. All right, so moving on. All right, let's take a look at a couple of examples here. So this first one, it says, starting balance of Anna's account is $1,250. She takes $30 out each month. So how much is in her account after 1, 2, and 3 months? So in the 0 month, right? So 0 will do months, which is X, and money, which is Y. So in the 0 month, before anything's taken out, she has $1,250. After the first month, she loses 30, right? Because she takes it out. So we go to 1,220, and 2 we go to 1,190, and then after 3 months, we go to 1,160. Okay? So basically, what you should glean from that or pick out from that is that we're subtracting 30 every time. So that's linear. We're adding or subtracting repeatedly. So our equation would be f of x, okay, is whatever our slope is, which in this case is negative 30. We're going down by 30 each time, times the number of months, which is x, and then plus the original value or the initial amount, the 0 amount, which is $1,250. Okay, and then to make sure it works, you should check and plug in numbers to make sure you actually do get the table that we already created. I'm going to save myself some time and say that we already do because I know we do, but in your problems, when you're creating them on the Walsh homework, plug it in and see. All right, I'm going to pause it there and then I'll create a second video for the last two examples.